Hello and apologies. We just had a slight technical issue, but we're very lucky to have Dario Sabella with us, chairman at ETSI's ISG MEC, and also at Intel. He'll be looking at multi-access edge computing, state of play from ETSI MEC and network automation perspectives. Welcome, Dario.
Thank you.
Hello and apologies. We had a slight technical issue, but we're very lucky to have Dario Sabella with us, chairman at ETSI's ISG MEC, and also at Intel. He'll be looking at more.
Hello everybody. This is Dario Sabella from Intel. I'm chairman of ETSI MEC. Sorry for the inconvenience of technical issues. And let me start now with my presentation. I'm going to give you an overview of the ETSI MEC standardization activities, also from a perspective on the network automation, which I think is quite interesting for you in this Congress today. So again, for the inconvenience, let's start very quickly. So we are going to enabling edge cloud, telco edge cloud through standardization with the ETSI ISG MEC. It's a standard body. It's an industry specification group on multi-access edge computing. So cloud computing at the edge of the network. It's a huge ecosystem. We are growing continuously with 112 members and participants so far, aligning with the 3GPP as well to enable fully standardized solutions, to enable application in distributed clouds. And I think this is quite important in this Congress also to point out the relationship with the AmericanNFV, because of course MEC is built on top of concepts which are defined by ETSI NFV framework for network function virtualization. So what is doing essentially MEC? This is the essence of MEC. If you can see in this slide a simple sentence defining what is doing this group. MEC offers to application developers and content providers cloud computing capabilities and IT service environment at the edge of the network. So practically, we are dealing with edge cloud and defining what's there, defined in the specifications, essentially identifying MEC platforms and enabling MEC applications, which are here, and the possibility to use and consume edge services through APIs. And of course, this is in addition to the current paradigm of client-server application. But definitely, we are also focusing on existential questions to applications on the edge. So, and that's what matters for application development. What if my users move? So all those things matter for application developers at the edge, as we are introducing really a new paradigm for application development with MEC, okay? So this is what the group is doing. We are defining APIs, but where do the API play their part? There are a couple of categories of APIs. As I mentioned, edge services. So we are adding functionalities that can be consumed by edge applications, and then application support, service management, radio network information, location, UI identity, bandwidth management, fixed access information, WLAN information, V2X information services. All those things that are increasing the portfolio of functionalities, enriching what are all the functionalities that can be exploited and consumed by an edge application. And then, of course, we have application package lifecycle and operation granting device application interface to connect from an external device application to the MEC system. Moving to our plan, this is actually a huge work since phase one it started a lot of years ago. We started with key specification, defining the architecture, initial set of APIs for management, infrastructure as a service, platform as a service, and key studies for MEC mobility support. And then we moved to phase 2, maintaining the APIs, evolving for mobility, enabling a regulation like low interception, and addressing key industry segments like V2X and IoT, and also adding new requirements for support for network slicing, containers, and also moving to normative work for the integration with NFV, and also clarifying that actually MEC is not mobile edge computing, it's multi-access edge computing now. And then enabling Wi-Fi fixed access also, not only 5G, which is of course very important and was also the focus for the work of MEC integration in 5G network. And then we continued our developer community engagement. I will talk a little bit about this important activity and testing and compliance. This is also very important for this group. And then now we are moving to the phase 3. We are completing outstanding phase 2 work, but we are already starting with the full phase 3 work, including MEC as a heterogeneous cloud, expanding traditional cloud and NFV lifecycle management approaches. So introducing MEC Federation, inter-MEC system, and MEC to cloud system coordination, mobile or intermittently connected components, resource-constrained devices, consumer-owned cloud resources. And then we are working on MEC deployments like MEC in Park enterprises, and continuing emphasis on enabling developers through other studies on application format and API serialization, MEC Sandbox, testing and compliance. And of course, we are continuing to define services that meet industry demand and completed APIs. So our standard is very complete of many aspects. I will give you simply what is our aim, which are the basic principles, because we want to keep an open standard approach, allowing multiple implementation, ensuring interoperability. We don't want to mandate all the standards which are already defined somewhere else, or maybe we want to keep also open to allow implementation in open source communities and proprietary implementations. Of course, we are exploiting ETSI framework, as I said, and definitions, then enabling deployment in NFV environments. We are aligning with 3GPP, of course, for making 5G, and this is very fruitful collaboration that we are having. And of course, as I said, we would like to maintain an access agnostic nature, so enabling other accesses and addressing multiplicity of use cases for a wide ecosystem, enabling multiple verticals like automotive, and also MEC Federation. We'll talk in a minute. So we're doing a different work, standardizing an application enablement framework and general API principle and guidance for designing API, because of course we are not aiming to standardize all the possible APIs, and that's absurd by definition because it's infinitive, right? We are just providing some relevant examples from the industry which are needed APIs to be standardized, but the general principles for the design are following RESTful languages and common practices based on TMF and OMA best practices, and this will ensure that a consistent set of API are used by developers. Then, of course, we are publishing specific service-related APIs, as I said, and management and orchestration-related APIs. So really, I will say our end customer, if you allow me, is application developer and application developer community. We want to produce simple to use, well-documented APIs, published also with Open API framework, In this forgeetsy.org website, you can find everything. Also related to our specification, you can see here the APIs, some of the APIs. And it's possible by following this MEC 009 API principle and guidelines for you to design your own API. And then to expose through the service registry in the MEC platform, this API to applications, edge applications that could consume the services. Also new APIs can be added, and we can create innovative applications quickly and easily and reduce time to revenue. And also increase the total addressable market. That's also a very good advantage for the MEC. Yeah, let me talk about, I think it's important for this Congress MEC in 5G, because it's of course very, very important for the this new system coming, and edge computing is a key asset for 5G systems. And we studied in the MEC 31 study item how MEC can be deployed, and also investigated the opportunities offered by the MEC to MEC by the 5G system and its edge computing enablers. Essentially, the MEC can be seen as an application function, the 5G system architecture. You can see here the picture related to all the elements, and the UPF is seen as a MEC data plane, the MEC architecture. You can see here also all the elements of the MEC framework that are mapped into the C-plane interaction with the 5G core. And let me mention as well our more recent work. First published in an ETSI white paper jointly by 3GPP and ETSI officials in July past year about this MEC harmonized architecture with SA6 EdgeUp. You know, because there is this work in 3GPP related to the support for edge applications in SA6 working group. And also this kind of alignment was captured by a technical specification 3.558, clarifying that actually there is a synergy between the ETSI MEC architecture and the EdgeUp architecture defined in 3GPP, and also possible mapping and correspondence of similar functionality, essentially the MEC platform, similar duties as the edge enabler server here. And also essentially a MEC application is the equivalent to an edge application server in the figure here. So talking about a MEC and NFV from a management perspective, this is also a sort of variant of the ETSI MEC architecture, mapping all the elements of the ETSI MEC architecture into the definition of the ETSI NFV framework. Especially, we see a MEC platform as a VNF and must be running for any other VNF up to run, and also the map manager is an MS for the map, and the application, the MEC application can be seen as well as a VNF, even if doesn't know it, of course. And MAPM is a part of the apps EMS, and the MAPM can be apps VNFM. So because we have to manage all those VNFs, including the application, MEC application lifecycle management. And of course, we have an introduction of reference points, MM1, MM3. Of course, this is MM3 starts as just a transformation from the traditional architecture, MEC standalone, to a MEC NFV architecture variant. And these are, of course, requiring APIs for application package management, for application lifecycle management, and lifecycle change notification. And these are the reference points also introduced like a hybrid, let's say, new reference points when you are moving to MEC and NFV, and then you have MV1, MV2, MV3 necessary to implement all the MEC architecture when we are moving to an NFV environment. So another topic that we would like to mention, very important, is the MEC support for network slicing. Of course, since we are talking about the MEC in 5G, also network slicing a key technology component for 5G networks, and it's important to allow multiple logical networks to be created on top of common shared physical infrastructure. So the study was aiming at understanding what is the role of MEC for that, and the support and the MEC tailored support needed to be provided, focusing on evaluating the gaps from the defined MEC features and functions, and identifying new requirements. So here, of course, you can see an example of a network slicing with MEC as the edge computing deployment with two different network slices and some elements customized for each slice, some other elements in common like the orchestrator. Then we have also another study which I think is relevant in the perspective of autonomous networks, because it's actually it's an hot topic in ETSI MEC. Currently, we are working a lot on MEC federation and inter-MEC system communication and MEC to cloud is system coordination. And this is I'm mentioning this study MEC 035. Which is analyzing several use cases. Actually, we don't have the time to talk about this, but it's a huge study. And among all the use cases, let me mention this MEC federation scenario of V2X services, where I think is quite relevant because you may understand, you may appreciate how heterogeneous is the system, including multiplicity of operators and the MEC vendors and suppliers and the car OEMs, and then implying a heterogeneous set of applications. So this is really a system, a use case where you need interoperability at different various levels. And in this case, MEC federation is a sort of must to provide this kind of V2X services, because you cannot imagine a system with only one operator in real cases in a smart city, or only one MEC vendor, or only one car maker, of course. And so in this case, MEC federation is needed, and ETSI MEC is working to update the MEC architecture and the relevant normative work needed to address the requirements from MEC Federation, in collaboration also with 3GPP and GSMA. So let me talk a few minutes about as well a working group that we created a few years ago called Decode. And this is about deployment and ecosystem development. So there are a lot of activities. We don't have actually the time to talk in detail about these things, but let me give you just some pointers with a list of activities which are aiming at expanding the ecosystem, encouraging the usage of MEC technologies across the ecosystem. And first of all, as I mentioned, the publication of open API representation for the in the ETSI Forge website, and a relative work related to testing and to conformance tests with publication of a standardized test suite, test implementation in robot language, and openly available and released under open source license. So this is a very complete and huge effort done by the group to facilitate the testing and interoperability and the conformance of MEC APIs. And of course, let me mention other activities, MEC Ecosystem Wiki, which is listing a set of exemplary implementation from many companies and partners, but also open source communities related to MEC specifications, and also proof of concepts and MEC deployment trials. You can see here the links of the public web pages, and of course, these are also related to a sort of framework encouraging new external submissions for POC and deployments and MEC ecosystem. So this is in the wiki page. You can see here mecwiki.etsy.org. You can find all the information, or also the contact email if you need more clarification. Let me mention as well the MEC Sandbox, particularly important for developers as a sort of simulator of a real 4G, 5G network, as seen via the MEC APIs. And I think quite understandable and easy to use for developers to practice with APIs. From a developer perspective, I think is a very nice example of what we are trying to do to approach them and to use our standards. And also let me mention other initiatives very quickly. So collaboration with open source communities like Akraino, with there is in their API portal a mapping pointing to some projects and blueprints which are also using and exploiting ETSI specifications, and some events and initiatives like MEC hackathons and also plug tests. So now we are approaching to the end, but I wanted to give you some pointers on the network automation perspective, because MEC deployments present challenging environments. We are addressing large scale from a geography point of view, but also small scale for cloud footprint, and with unmanned location and outside traditional service areas. So in a wider sense, we have also to support critical infrastructure, so telco, public safety, with a lot of requirements in terms of availability, reliability, nines. So it's a unique set of requirements and processes. And also for automation perspective, there could be the need to minimize the need for human presence, maximize the service time intervals, minimize skills required from those on site. In other words, get as close as possible to the web scale maintenance model in a very non-web scale environment. That's the challenge, I think. And also some pointers about the specification. Of course, MEC maybe is not the biggest stakeholder in this field, but we are collaborating with the ZSM and NFV or SM, which are respectively managing the overall approach, and the telco cloud, while MEC is focusing on managing the edge telco cloud. So this is actually the scope, I think, relevant to network automation in the context of this Congress. And then let me go to the conclusions, and sorry for running, but we started late due to the technical issues. Let me go to the conclusion quickly. So ETSI MEC is the leading voice in standardization industry alignment around MEC with the access edge computing. I mentioned the relationship with the key components like NFV, network slicing, 5G, and multiple use cases. I mentioned as well some key important aspects that are for the MEC deployments in the perspective of autonomous network, like MEC federation and network slicing, which are key MEC use cases for network automation, as I said. So thank you again for your attention. Thanks.
Thank you very much, Dario. Up next, we'll be having the ETSI Ghana Forum. So please make your way to